Hello there, my name is Oidera and today I have an exciting video for you. I'm going to be covering design patterns in particular. I'll cover many and in particular I'll go in depth when it comes to factory, repository and singleton patterns. Welcome and enjoy, and I hope you leave your questions. Looking forward to it. Let's look at design patterns. So what are design patterns? They are reusable solutions to common problems that occur in software design. So, long ago, people figured out that there's these things that keep being repeated over and over again. So, instead of doing that or having complicated ways to do it, people came up with best practices that have evolved over time to now solve for the solution. So, instead of reinventing the wheel, instead of creating new solutions every time to recurring challenges, we now have templates that we can use for solving these challenges. And that way, it's some sort of a uniform way of handling these things, these common problems throughout software. So, design patterns can come in different forms and different stages of the software development cycle. I'm going to cover that in a different video. Today, I am not going to go in depth into the many different types of design patterns. Not many, there are like three, but within the three, there's many ones in under that. So let's go to key benefits of using design patterns. What are the benefits? So, one, code reusability. You write once and apply as many times across the projects. You don't have to keep repeating this code because you already have it, and you'll see examples of this where that's the case. Actually, the three patterns I'm going to cover today will show reusability pretty much. Maintainability, because you have a standardized approach, it makes code easier to understand, easier to maintain, easier to even collaborate with other team members, as you're going to see. Scalability, flexible and adaptable software, scaling up and down because you're already working and everyone knows exactly what you're working with and everything is defined from the word go. So changes are easier to add and take out because of that reason. Collaboration and communication, you now have a shared vocabulary among your developers, so that will mean easier understanding of the code, easier working on the code base to start with. What are the commonly used design patterns? These are the most commonly used patterns. As I said, there's many more. These are just the commonly used ones. We have factory pattern, we have singleton pattern, we have repository pattern, we have observer pattern, we have strategy pattern, we have adapter pattern, and we have decorator pattern. So let's see, what is factory pattern? So basically what factory pattern does is it centralizes object creation. Instead of using the new keyword everywhere, every time I want to instantiate a class or something, the responsibility of creating objects is delegated to a factory class. We're going to see that. So singleton pattern, it ensures only a single instance of a class is created. This is commonly used for logging, caching, configuration objects. Also, we'll see an example of that. Luckily, repository pattern, it abstracts the data access layer. Therefore, the business logic becomes independent of database details. So, whatever data store you choose to use, that's none of my business as the repository. I just give you the methods you're going to be working with. And then you can implement it as you wish in your specific data stores, whether it's in memory, whether it's whatever you're going to use. The fourth one is observer pattern. So it establishes a publisher subscriber relationship. It is used to notify objects when there's change in another object. When an object changes, all subscribers are notified. So, in case you're not familiar with the publisher subscriber model, let me give a good example. A good example could be, yes, the weather. That's a common example I see. The weather system has all these parts to it, and I, as a user, let's say a different system or another system, could subscribe to the weather system so that I get update anytime there's a change. I get notified and then I can shift accordingly. Let's say there's a new prediction and that the rainfall will be high. I'll not carry an umbrella. I'll not dress warm. That it's going to be sunny. I'll know to dress my cute clothes, my crop tops, and sundresses and all that. So that's the observer pattern. Strategy pattern. It encapsulates algorithms in a way that allows them to be interchangeable. The client does not need to know which algorithm is being used. The strategy is provided externally. So, how you implement things internally, that's none of my business. Just I want to know that it does what I want it to do. That's all. That's my concern. And then we have the adapter pattern. It allows two incompatible classes to work together. It is often used to integrate legacy libraries or APIs into new system. So let me give an example of this. Let's say I have two versions of user. Let me use user as an example. And user has ID, full name, that is version 1, and version 2 has ID, first name, middle name, last name. So these two structures, these two classes are different in structure. And the app maybe is wired to work with one and not the other, or vice versa. So because of that, the adapter comes in where it now translates for the application from full name to the parts or the parts to the full name. That way, whatever version of user you give it, it is still able to work with it. So that's what ideally the adapter pattern does. And lastly, we have the decorator pattern. It allows adding new behaviors dynamically to existing objects. Comparison based rather than inheritance. A good example of these are, of course, yes, the decorators. You'll have your specific methods, has nothing to do, this functionality that it now inherits is not from inheritance. It's just a matter, like in Python, it will be at and then the name of the decorator. And now moving forward, that method, that class will now have the behaviors attributed to this decorator that has been supplied to the method, to the class. So, in this session, we're going to explore two essential patterns. We have the factory pattern, and so factory pattern for flexible object creation, and repository pattern for clean data access abstraction. So, let's dig into the factory pattern. A creational design pattern that provides an interface for creating objects in a superclass and then the subclasses to alter the type of objects that will be created. So it deals with the problem of creating objects without specifying the exact class of object that will be created. I feel like this is more wordy. You get the idea at this point, but anyway, so it is achieved using the factory method rather than calling the constructor directly. And we'll see the parts where it's more where like so aside from this, like doing this work for you, I don't have to worry about the things I need to set up before creating this particular class. The factory does that for me. I don't have, every time I need to instantiate a class, I maybe need to instantiate another one and another one to now have them go into this. That's not my business. As like the code will not be concerned with that anymore. Apart from the factory class, that is, so it abstracts the object creation process. Do what you need to do. That's not my business. I just want this at the end of the day. And every time I call this, it does this for me. It crafts object without the fuss of revealing their origins, their backstory and all that. It makes a database model class. It takes a database model class and returns a new class that has all the CRUD functionality needed attached to it. So it does the creation, and then after that, you can do what you need. You can read, you can update, you can delete. Something to note here, the factory pattern does the C. It's the C in CRUD. So why should you use the factory pattern? I feel like you can get this from the previous explanation. Object creation can become complex and repetitive, and that's why this comes in and helps you with that. And then it encourages loose coupling between classes. And lastly, it simplifies the process of extending applications by introducing new types. Let's look at an example of this in the real world. Let's say we now want to create a notification system. So a notification system can be implemented. It can be in form of SMS, it can be an email, it can be on call, it can be push notifications. All these are different types. Notifications can be relayed to a user in case the user, they usually the end the the person interested in the notifications to start with. And so what we do is now have a common factory method that now does creates notifications that will now be implemented differently by the different applications. So we have this standard one, and then the other ones, instead of having instantiating when we're creating it for the email, and then instantiating it when we're doing it for the SMS and the push, we do have this one instance, and then the others will use it and then build up on that. When do we use it? So we use it when an application needs to create multiple related objects dynamically. We've seen that example. So same concept, but implemented differently. When direct object instantiation leads to tight coupling. And lastly, when complex initialization logic is involved. Now that's it on factory pattern. Let's go to repository pattern. What is that? What does it do? It separates the way data is stored and retrieved from the business logic of an application. So if I keep saying this, but I am not interested in how you implement it. These are the methods. This is the methods I'm going to need in my application. So I'm going to list them, and then you choose how to implement it. It can be an in-memory data store, like store. It can be Kafka. It can be, relational, non-relational, whatever storage you use. That is none of my business. That is absolutely none of my business. Acts as a bridge between the application's business logic and the databases or data sources. The key idea is to have a central place that handles all data access operations, making code cleaner, more maintainable, and easier to understand. It offers a consistent way to access and manage data while hiding the details of the underlying data store. Repository pattern advantages. We do, of course. And like I mentioned, just like factory pattern, you can easily deduce this understanding what it does in the first place. It separates the way data is stored and retrieved from the business logic of an application. It improves testability by allowing data sources to be easily mocked or replaced. And because of this, you can literally have a mock repository separate from the whole application that now handles this for you, like that is implemented differently without interfacing with the main application without interfering with it whatsoever. It provides a centralized and standardized approach to data operations, which increases maintainability. Because we have this common way of doing things, it's easier to maintain. Everyone is on the same page on what we're doing, on the direction, on, if I add a new method to the repository, to the abstract class, that means this will also need to be implemented in the implementations in the concrete classes. It makes applications flexible and adaptable to changes in data storage technologies without impacting business code. What are some real world examples of this? I used librarian here and a shop attendant, a supermarket attendant. A librarian already has the format in mind, knows everything where it's stored. So instead of now taking my time to go through all this, I can easily go through them and then tell me what I don't need to understand why you even went to this format, why you put these books here and not here. That's not my business. I just need a book. I come help you, and then you do that for me. You direct me to where the book is. Same case for supermarket. I'm less interested on why you put the shoe polish far away from the milk. I mean, I could know, but that's not my concern. I just need milk. So please direct me to the milk. Even though it's pretty obvious, go to the fridge. But you get the idea. Shoe polish, no, those that you need instructions, directions if you're in a rush. If you're not, take your time. Please explore the whole supermarket. It is, the program asks the repository to find, save, update, or delete the data it needs. So does the RUD. The C was factory pattern. Now the RUD, the repository. So everything after the creation now falls into the repository. What are the disadvantages? I put that in quotes because are they really disadvantages? In small applications, it adds unnecessary complexity, hence becoming more cumbersome than useful. What is a small application? I mean, all applications could use efficiency, but anyway, I do understand. I'm kidding, but that's also why I'm also like, I'll still lean towards that because I feel like you start out thinking it's a small application and then it grows, but of course, there is actual real small applications that maybe you'll never have to use again, that maybe you need for a hackathon. I don't need perfect code. Sometimes I just need the code to run. So I guess in that case, or a script, I don't need to complicate it. Also, why are you having such patterns in a script? You know, that's on you for exaggerating code for the sake of it. It takes time to set up interfaces and repository classes, which can delay project timelines. Again, same thing. Technical debts. I would rather take my time at the start and build very, very clear structures that are smooth to work with than struggle later. But hey, that's me. But also, again, depends on the application. If I'm doing this for maybe a hackathon, not so much. But here's the thing, once you get these things and they are normal for you, it becomes easier. It's not that complicated to implement them even on small applications, which they would still use the efficiency to start with. And lastly, this is our last disadvantage. Sometimes the details of the underlying data access layer can leak into higher layers, reducing the effectiveness of the abstraction. So that's something to be wary about. So the next part is I want us to go through an example flow for demonstration. But before we do that, um, so basically, as you've seen, the factory and repository. I've actually done a video on this before when I was doing the domain-driven design course. So I'm going to attach the video so that you look at it. But I was mostly focused on theory. I was mostly focused on people understanding the concept and less the code. And people like to see the code, but I feel like for concepts, these concepts you need to actually understand before jumping into just implementation because that steals away from you understanding the details. But worry not, this video does have examples. And I'm going to explain this thing before we get to it. So we'll find that actually I'll explain when we get there. So I'm going to use a to-do list application, the most common example, because right, a simple to-do list app that demonstrates the core building blocks of a small task management service. You know, look at how they are overwhelmed. Very, very. To-do data structures, models, a task with an ID, title, optional description, and completed status. So we're seeing that I used Python for this because it's easily readable for most people. So yeah, basically does that. Our data classes ID, title, description, completed, and in the representation we can now check whether we can now add status. That's on the representation level. So we needed the structure. Now, we are going to now create our repository. This repository is going to be abstract because, again, this just defines the methods we need. So defines standard operations for managing tasks, including add, get, update, delete, and list. And as you can see, not implemented. They're not implemented because this is not where the implementation goes. This is an abstract class. So the implementation now goes to the concrete methods, the concrete classes. What's another thing to note here? Add is here. And as I mentioned, add belongs to the factory. But we now have it here. Why? So it's common practice to find this where people have the the create inside the repository because as you can see, most of the other methods, like every other method belongs here apart from this. So instead of having now a to-do factory, it's common practice to find people now have these, or sometimes, which is rare, have it as a factory instead, but interchange these, but basically have the methods, the CRUD methods in one place as an abstract class, or whatever you're using, whatever programming method language you're using. And then after that, then the implementation comes later with this. But ideally, add it here because it's just one method instead of now having more code for the sake of having more code just to say you're following rules. That's what's happening here. So, in case that's something you're curious about, that's why we have add inside the repository, even though technically it doesn't belong here. It's cleaner that way. We are also trying to be practical, and not just be messy extra for the sake of it. And now here we have the implementation. And this is an in-memory to-do repository. We used a dictionary for this. So in case you need this code, I can get it for you. I didn't put it, it's not anywhere yet. So, but I can do this. I'll only do this on a demand basis because I didn't think it's little code, so I assumed someone could easily just figure out what's going on without. But if you need it, please don't be shy. I'll respond and I'll create that and I'll post it for you. And then finally, we have a main class implementing this. So this shows the usage for creating, for listing, mark, complete, fetch a specific item, and delete. So you can see here repository.add. We can see listing the ones and then updating using the ID. We have retrieving using an ID, deleting using an ID for the first to do. And lastly, give me the list of what's left. So what are the use cases of factory and repository patterns? We use them on our web apps. That's a very good application. It makes it easier to switch between different database systems, data stores. We'll use them in our apps and services because it organizes data access and ensures consistent interactions with data. Large systems, very, very efficient for such systems because it helps keep data access logic tidy, making the code base easier to maintain. Testing environments, I mentioned you can literally have a mock repository in testing, allowing you to simulate data access without affecting real data. And lastly, data migration, moving data between databases. The repository makes transitions smoother by allowing you to swap implementations while keeping the app intact. Because we maintain the abstract class, how you implement it is none of my business. You can have it go to Kafka, you can have it go, that's none of my business. Because of that, you can just switch over very easily and the application will continue running the same way. The repository, basically, the repository pattern lets us have an access layer for a single model. So what happens after the creation? We read it, we update it, we delete it, we find it, all that. And the factory pattern lets us create an access layer for any model, so the creation. And I have a bonus. Let's look at it. The singleton pattern. What is it? So it ensures a class has only one instance and provides a global point of access for that instance. It is useful when maintaining a single instance is essential for proper functionality. We'll see this, so don't worry. So why should you use singleton to begin with? It prevents unnecessary duplication of objects. There are some cases where you don't want these duplicates whatsoever, so then it comes in that place. It controls shared resources of an application. And lastly, ensures consistent access to a global instance because once this singleton is created, you can access it from anywhere in the application. A good example of this is the database connection manager. You do not want an instance, if for instance I'm dealing with Postgres where I have an instance here and then I have like where the create is adding to this instance, where the get is using another instance, then it's so many threads to keep up with, and you also need a centralized system where, so you don't want that. You want one instance so that you're working with the same thing every single time. So instead of creating multiple database connections, the singleton ensures that only one connection exists throughout the application lifecycle, optimizing resource storage. What are your benefits of using Singleton? It prevents multiple instances. Only one instance of the class exists. You don't want many of those. Benefits global access point. It is accessed from anywhere in the application. And lastly, resource management. It optimizes resource management. It reduces redundant object creation, improving efficiency. So when should you use singleton pattern? When exactly one instance of a class should exist throughout the application. There are many cases of this. There are different cases of this as listed when managing shared resources like logging services. When logging, you want to work with the same instance for easy tracking. You don't want, so that all logs are going to the same place and you can literally monitor easily. Caching systems, same case, config systems, DB. And when implementing thread safe operations that require centralized control. A good example, like I mentioned, is your database connection. What are the challenges? Overuse can lead to tight coupling and hidden dependencies, making code harder to test. So do not overuse. And this is more of a nice to know, or it's still a challenge in that you need to know. Single instances must be thread safe in multi threaded environments to avoid concurrency issues. So that's a challenge. You need to be aware of that when working with concurrent systems because you have many threads running and you have to keep track of all so that you don't have your code. You need to, like, resource management is a big deal, mostly in wastefulness, and also you want to track your things. You don't want to have a job running and you don't know where it goes, what happened to it. You want to keep track of all this. And that's it on design patterns. Okay, I mean, there's more. There's more into design patterns than that, but specifically, I was focusing on factory pattern, repository pattern, and as a bonus, singleton pattern. So that's it from me, from Codarasa. I'm going to do another video maybe later where I cover more on design patterns without now drilling into the tree. It will be more broad and explaining many more ways you can go with this, you can explore the world of design patterns. Anyway, that's it from me. I am Waithira from Codarasa, and I hope to see you again. This time I'm staying around. I won't go a wall for a whole year again. This time this time, not I think, I know for sure I'll be around. So follow for more and happy learning. Feel free to ask as many questions as you want. Bye.